Good morning, grade 8s. Hope you are having a marvelous Monday attending our online lessons. So welcome to WorksheetCloud's grade 8 natural science lesson. If you have any questions during the lesson, please email us grade8worksheetcloud.com. I have a quote that I'd like to share with you today. The difference between ordinary and extraordinary is that little extra. And I just want to thank each and every one of you for being extraordinary individuals during this time. I am sure that your teachers are going to be really pleased with the extra effort that you are putting in to continue your learning. I know I am extremely proud of you. My name is Mrs. Ernston. I am WorksheetCloud's grade 8 natural sciences teacher. Please be prepared for today's lesson. So get your pens and paper ready and remember to take notes as we discuss things in our online class today. This is our topic for today's lesson. We're looking at chemical formulae and chemical reactions. So what I'm hoping that by the end of this lesson, you will know how a compound is different from an element, what holds molecules together, what happens to atoms and molecules during a chemical reaction, how to write a chemical formulae, and you are going to be using models and simulations in science to deepen your understanding of abstract concepts. So you might need to pause the screen and dash off and go and collect some things for this lesson. You need things that are different colors and you need a variety of things. So something like bottle top lids or beads or sweets or Play-Doh or coins. The important thing preferably is that they're spherical, so they're circular or rounded in some way, and that you have a couple of different colors. Maybe 4 or 5 different colors should be enough. So if you just pause the screen, and I'll wait for you to get back. Okay, I want you to keep a list throughout this lesson of all the elements that we mentioned in class today. And I want you to write the name of the element and the symbol. So pens and paper ready. This periodic table is a really good link to refer to throughout the lesson. And it has everything that you need on it. So if you need to keep on coming back, the time at the bottom of the screen is about 3 minutes 20. So if you need to come back to the periodic table, just jot that time down, 3 minutes 20, and you can come back and access the periodic table whenever you want. So can you remember that each element has its own unique chemical symbol? You should have had a look at this at grade 7, but if you haven't, not a problem. I'll go over it again now quickly. So I want to see if you can finish the first 20 elements on the periodic table. You may need to pause the screen for a moment while you complete this activity. But before you go on to answer the questions, what I just want to remind you quickly is how we use symbols to name the chemical elements. When we name chemical elements, the rule that we tend to follow is we use letters. And you're either going to use one letter or 2 letters. So if we have a look at the example here, for hydrogen, we use a single letter, H. Now, when we go down to helium, we can't use H again because it's going to be the same as hydrogen. So we look at the first 2 letters of the elements and we use 2 letters in this case. When writing the chemical equations, please, the chemical formulae, please remember that the first letter is always capital and the second letter is always lowercase. So you can pause the screen now. And here we have your answers. So we can go through and just check your work quickly. The one thing I do just want to remind you about, and I know your teachers will be really, really grateful, and that is when writing elements and symbols, please be very mindful of your handwriting. It is very important that you clearly differentiate the capital letter from the lowercase letter. And other areas that you need to be really careful are is when writing an L and an I. So for example, if we have a look here at aluminium and silicon, sometimes with your handwriting an L can look very, very similar to an I. So please be careful and write nice and neatly when you are writing the symbols for the naming of the elements. So how did you know if substances are elements or compounds? Have a look at the diagrams here and see if you are able to work out which of these are elements and which of these are compounds. You probably looked to see which ones were made up of only one kind of atom. And if we have a look at this diagram here, it's only made up of one kind of purple atom. And this diagram at the bottom here is, even though the two atoms have chemically combined, it is still only one type of atom. And then a compound is a material that consists of atoms of two or more different elements. So if we have a look here we have one atom of an element represented by red, and we have two atoms that are represented by the white dots. Back into a little deeper into this question. So how do we know if substances are elements or compounds? So how would we go about assigning an element to these diagrams? So oxygen gas, which we write as O2, hydrogen gas, which we write as H with the lowercase 2, and nitrogen gas that we write with an N and a lowercase 2 are examples of elements. Now you might be wondering, what does this lowercase 2 refer to? Well, that is all about something that we learnt in a previous lesson known as diatomic molecules when we looked at atoms and elements and compounds and molecules. So you can go back to the previous lesson and refresh your memory on that. Now, if we've got to draw O2, for example, the 2 over here refers to the number of atoms in one molecule of oxygen. So here would be 2 atoms. In this diagram here, we have 2 atoms that make up one molecule. So how does this compare with a compound? Well, in a compound, you're going to find 2 different elements. So in this diagram here, we have water and oxygen. So oxygen is represented by the red dots, and water is going to be represented by the 2 white dots. In this diagram over here, we have carbon dioxide, which means we have 1 carbon atom and 2 oxygen atoms. So the carbon atom here is going to be black, and the oxygen atoms are going to be red. And then if we have a look at another compound called sodium chloride, made up of Na and Cl. So at the bottom here, there's an invisible 1 here. So it means it's got 1 atom of Na with 1 atom of Cl. So there we have NaCl. Each compound has a unique name. Now, why is this name so important? Well, firstly, a compound is a substance that is formed when 2 or more elements combine together chemically. Just a reminder that the atoms combine in a fixed ratio. So if we have a look at this example here, we have 2 different types of atoms, a red atom and 2 white atoms. So we know that we represent these 2 white atoms represent hydrogen, and this red atom will represent oxygen. So this compound here is known as water, or H2O. So why is this so important? Well, what if we have a look at this compound here? And how does this compound now compare with this compound here? Well, it has an extra oxygen atom. It is no longer water. It is now known as H2O2, the common name for that being hydrogen peroxide. So when we're writing chemical formulae, how do we take this diagram and turn it into a chemical formulae? So it's a chemical formula for water is H2O. You know that by now. So here are the two hydrogen atoms and here is the oxygen atom. So it shows the ratio of hydrogen atoms, which are the two white, to oxygen atoms, which is the one red, in one molecule of water. For this stage, please do not worry about trying to learn or understand how we name compounds. This is something that you will learn in grade 9. It is one of the grade 9 lessons coming up this week. So if you want to go and have a look at the lesson, please, you are welcome to go and learn about naming compounds, but you don't need it for grade 8. The only concept I want you to understand in today's lesson is how do we use the periodic table and ball diagrams to write the chemical formulae for elements and compounds. And this is where we need you to have your Play-Doh or your lids or your coins or your beads or whatever you got. So have all of those things ready. In this activity, we are going to practice writing and understanding chemical formulae. It is always a good idea to think about a new concept in many different ways. And I think this is going to be a lovely hands-on activity for you to try and learn these abstract concepts. So we are going to be building molecules and writing chemical formulae at the same time. So what do you think the chemical formula CO2 tells us? Well, let's go back to the periodic table. The C refers to carbon on the periodic table, and the O refers to oxygen on the periodic table. And if we have a look here, the subscript here is invisible 1 for carbon, and the subscript here is 2 for oxygen. So that means that we have one atom of carbon, the black atom, bonding with 2 atoms of oxygen. So now you can use your Play-Doh and you can build this model so long. What do you think the chemical formula NaCl tells us? And what I've done is I've put a diagram in for you to have a look at it. So you can build this model now quickly. Remember to use 2 different colors, one color for Na and a different color for Cl. So let's now link this up with the periodic table. We need Na and we need Cl. And in this diagram, there is only one atom of Na and one atom of Cl that chemically bind together. This substance is known as sulfur dioxide. So let's refer to the periodic table and see if we can find these elements. So sulfur is S and the oxide here refers to oxygen. The di refers to 2. So in a compound of sulfur dioxide, we have 1 sulfur atom and 2 oxygen atoms. So if we had to write this out, it would be SO2. S with an invisible 1, meaning 1 atom of sulfur, and O2, meaning it has 2 atoms of oxygen. The substance we'll look at now is dihydrogen sulfide. So here is the ball diagram. So you can build this diagram so long. So you need 1 ball to represent sulfur atom, and you need another 2 balls to represent the 2 atoms of hydrogen. So how do we write this chemical formulae? We go to the periodic table and we go and look for the elements. So there is hydrogen, and we need 2 atoms of hydrogen, and there is sulfur, and we need 1 atom of sulfur. Now I know some of you might have wanted to write this as SH2. Again, this concept of naming compounds is covered in grade 9. The substance we will look at now is oxygen gas. I'm going to give you a little bit of a hint. Remember that oxygen is a diatomic molecule, so it is made up of 2 oxygen atoms. So we go to the periodic table and find oxygen, and now you can build your oxygen molecule. And once you've built it, it should look something like that. 2 circles of oxygen, and we write it as O2. This 2 representing the 2 atoms. The substance we're going to look at now is hydrogen gas. Another hint here, it's a diatomic molecule, so it is going to be made up of 2 hydrogen atoms. So you go to the periodic table, you will use the symbol H, and now you can build your 2, you can get your 2 hydrogen atoms ready and put them together, and we write that as H2. We have another substance that is known as chlorine gas, and if we have to build a model of it, this is what it will look like. So if chlorine gas is made up of 2 balls, how will we write that chemical formula? So you go to the periodic table and you look for the symbol chlorine, and you need to remember that we have 2 atoms. So we will write it as Cl2. Please remember to have a capital C, and the L must be a lowercase l, and a subscript 2 to show you that chlorine gas is a diatomic molecule made up of 2 atoms. Another substance we're going to have a look at now is ammonia. The hint I'm going to give you is that it is made up of 1 nitrogen atom and 3 hydrogen atoms. So I want you to get your balls of Play-Doh out, and I want you to see if you can build that molecule so long. You can pause the screen if you need to. If we have a look at the periodic table, here we have nitrogen, and here we have hydrogen. And you need to have 1 nitrogen atom and 3 hydrogen atoms. So we're going to write that as N, okay, with the invisible 1, because there is 1 nitrogen atom, and then you're going to write H, And because there are 3 atoms, you put 3 as a subscript. Now I wonder what your molecule looked like. And I'm hoping it looked something like that. 1 nitrogen atom and 3 hydrogen atoms. The substance we'll look at now is nitrogen gas. So we go to the periodic table and see if you can find the element nitrogen. The hint I'm going to give you is that it is made up of 2 atoms. So we write that as N with a subscript 2, showing it's made up of 2 atoms. And now you can make your ball diagram quickly. And that is what your diagram should look like. So, yes, nitrogen gas is also a diatomic molecule. So using a model or a simulation in science, it might be a good idea to write down some of the things as we go here. And this is something really important that you share back with your teacher and with your class friends when you get back to school. I know that often teachers like to put this in tests and exams as well. So let's pay special attention. You could possibly get questions like, how does the model best represent writing chemical formulae for elements and compounds? So what I mean by that is, how did using Play-Doh really help you to understand the writing of chemical formulae of elements and compounds? How could this model lead to some misconceptions, or how could this model result in a poor understanding of chemical formulae and elements and compounds? And what instructions would you change, or what improvements would you make to this activity so that we could better use models and simulations to represent chemical formulae? This is definitely a tricky question, but if you spend some time thinking about it, you will deepen your understanding of how to write chemical formulae for elements and compounds. So if we have a look at some of your answers here, how does the model best represent writing chemical formulae for elements and compounds? Well, one of the great things that it does is you can use the balls of Play-Doh or buttons or whatever, and you can pick certain colors to represent certain elements. So that's the one thing you can do. The Play-Doh can also easily be rolled into a ball to represent an atom. So I think for this activity, you definitely need something rounded that will help you represent the concept of an atom. The use of different colors is also a good idea, because different colors can represent the different elements. So it is a wonderful visual representation of how the atoms chemically combine. How could this model cause misconceptions that could result in a poor understanding of chemical formulae for elements and compounds? Well, number one, if you don't use the different colors to represent different elements, it could lead to a misunderstanding. The other thing that it might not show is the relative size of the atoms. So we need to remember that the lower down on the periodic table, the smaller the atom. And the higher the atomic number, the larger the atom. But I didn't highlight that today because that is something that we sort of cover in grade 9. But if you have a misconception in grade 8, it can cause you to have a poor understanding later on in science. So that could be a misconception. The other misconception is that an atom is actually a round solid ball. It's not that. You will remember for our lessons on the structure of the atom, it's actually a central nucleus made up of protons and neutrons with a cloud of electrons surrounding that nucleus. So we could get misconceptions on the structure of the atom. And for this question, I wish I could hear your answers and see your answers. So you are more than welcome to email them to grade8@worksheetcloud.com so I can actually see what great ideas you had and what improvements I could make to this activity. So I welcome all your suggestions here, and I'm sure you came up with great ideas on improvements that you could make to using this model to represent chemical formulae. So what is the similarity between these two images? If you need to pause the screen while you jot some answers down, please do. Well, we haven't covered magnets in our online lessons yet, but you might have done it at school or in some of your lower grades. But magnets attract or repel each other because of a magnetic force that exists between them. So the one similarity that I can think of is that when atoms combine, there is an attractive force that holds the atoms together. So the forces that hold atoms together are known as chemical bonds. So the water molecule has two identical OH bonds. So it's going to have an OH bond over here, and it's going to have an OH bond over here. So what would happen if we had enough energy to break these bonds? Well, we'd be left with a separate oxygen atom and two separate hydrogen atoms. So what would we have if we separated water molecules into their atoms? So here we have two water molecules. Here is one molecule and here is another molecule. So the red represents an oxygen atom and the white represents hydrogen atoms. So if we separated water molecules, we would find that the hydrogen atoms recombine to form hydrogen gas, and the oxygen atoms combine to form oxygen gas. And if we write that as a chemical representation, we write the compound water as H2O, and that gets broken down into two molecules of hydrogen and two molecules of oxygen. When atoms separate from each other and recombine into different combinations of atoms, we say that a chemical reaction has occurred. So water has been decomposed or broken up and recombined into smaller molecules. Just a reminder, we say that water has undergone a decomposition reaction. So not all chemical reactions are decomposition reactions. There are many kinds of different reactions. And if you stay tuned to tomorrow's lesson, we have got a great practical experiment where we're looking at exciting chemical reactions. So stay tuned, and I look forward to seeing you tomorrow. So just a recap on chemical reactions. Two important events happen in all chemical reactions. One, chemical bonds break, and two, new chemical bonds form. So this means that in all chemical reactions, the atoms in the molecules rearrange themselves to form new molecules. So you can go back now and you can use your model to simulate this chemical reaction. So I want you to simulate the decomposition using any type of spherical structures to represent the different atoms. And I've put the decomposition of water here to help you with this little activity. You may need to pause the video to build your molecules of this decomposition reaction. Great, I hope you had fun today. So just to recap, that we covered chemical formulae and chemical reactions. So you should be able to explain now how is a compound different from an element. You should be able to remember what holds molecules together, what happens to atoms and molecules during a chemical reaction, how to write chemical formulae, and how using models and simulations in science deepens your understanding of abstract concepts. So, what have you learned today? So, for your last activity, I would like you to make a summary on chemical formulae and the naming of compounds. But here is your challenge. You are only allowed to use pictures. If you do have any further questions, please remember to email grade8@worksheetcloud.com. Enjoy the rest of your marvelous Monday. Continue to be extraordinary, and well done for taking responsibility for your learning. Thanks for watching Grade 8s. The lesson was brought to you by WorksheetCloud. So please go and download the worksheets for today's lesson and have fun seeing if you can answer some of those questions and do some of those activities. I'm looking forward to seeing you all tomorrow. Bye.